Hey everyone, welcome back to The Explainer. Today we're diving into one of the most fascinating evolutions in the tech world, the journey of software architecture. If you've ever wondered how the digital tools we rely on every single day grow from simple applications into massive, globe-spanning platforms, you are absolutely in the right place. Let's get right into it. It's the million-dollar question, isn't it? Is there some magic scaling sauce out there for software architecture? A perfect one-size-fits-all design that just automatically handles any amount of traffic you throw at it? Well, according to engineering experts, the answer is a resounding no. Architecture isn't about finding a silver bullet. It's a constant, ongoing practice of managing complex and sometimes really painful trade-offs. Okay, let's dive into this. We're going to trace the natural life cycle of a growing app, starting with the monolithic foundation, what happens when you hit the wall of scale, moving into distributed architectures, weighing the trade-offs and fallacies, and finally, how to actually evolve your system. Section 1, the monolithic foundation. So this is our baseline. And honestly, it's exactly where almost every great software system rightfully begins. A monolithic architecture is basically a single deployable unit. It bundles all your system's functionality into one process, usually hooked up to a single central database. It runs on a shared memory architecture. Everything you need is right there in one place. This perfectly captures how all your different domains, say you've got an auctioneer, a bidder, a video streamer, a payment processor, they're all tightly packed together. They execute in process within the exact same system block. There's no crossing network boundaries to talk to other parts of the app. It's just one cohesive unit. Now, I know the word monolith can sometimes get a bad rap in tech circles, but it really shouldn't. These applications are incredibly successful starting points. They give you a 5-star rating in simplicity, which, let's face it, is a rare treat for us. They're super simple to develop, you can test them right on your laptop, and the initial cost is incredibly low. Plus, you totally avoid complex network latency because components just talk locally in memory. They are lightning fast when you're just starting out. Section 2. Hitting the wall of scale. But as your user base and complexity inevitably grow, the friction kicks in. Nicole Forsgren points this out perfectly in the book Accelerate. Quote, "If deployments have to be performed outside of normal business hours, that's a sign of architectural problems that should be addressed." That right there, those painful, brittle, out-of-hours deployments, that is your very first major warning sign that your monolith is struggling. Under sustained pressure, the cracks really start to show. First up, you get hit with single quantum scaling. If only your payment processor is getting hammered with traffic, you can't just scale that one piece. You have to copy and scale the entire massive app. On top of that, failure isolation is notoriously poor. One tiny memory leak and some obscure feature, boom, it crashes the whole ship. And the human cost is just immense. Your engineering teams are tied to these massive complex release cycles where developers sit around for weeks, waiting on other teams before they can safely deploy. And what's really interesting here is what happens when you try to force that monolith to scale. You can throw in as many web servers as you want, spinning up dozens of clones horizontally, but eventually all those connections just funnel right back down into a single central database. That database becomes a massive, inescapable bottleneck that throttles everything, no matter how much compute power you throw at the front end. Section 3. Enter distributed architectures. To smash through that monolithic wall, we need a total paradigm shift. Scaling up vertically means buying a bigger, way more expensive machine for your monolith. And that cost goes super linear really fast. But scaling out horizontally, that means distributing the load across multiple, smaller, independent machines in a shared nothing setup. And the beauty of this is that, thanks to the cloud, you don't need massive Google-scale resources to afford a multi-region setup anymore. It's accessible to pretty much everyone. So what are we actually talking about when we say distributed architecture? It's an application made up of multiple, independent services instead of one giant block. Each service runs in its own process, in its own little ecosystem, and they chat with each other over a network. The state of the application is spread out. This lets you run operations in parallel and asynchronously, totally freeing you from those single-point bottlenecks. Look at how this shifts the dynamic. In a true microservices setup, that dreaded database bottleneck disappears because each individual service has its own decentralized database. This is exactly how massive players like Netflix operate. They give their individual engineering teams complete ownership to choose their own tech stack and deploy on totally independent schedules. That decentralized governance completely solves the deployment brittleness we talked about earlier. It lets huge organizations move incredibly fast without constantly breaking each other's code.
Section 4. The trade-offs and fallacies.
But hey, before we declare total victory, we have to remember the golden rule of architecture. Every cure is also a curse. Distributing your system completely changes how things communicate. You're trading a blazing fast, instantaneous, local, in-memory call, where everything just talks instantly inside one machine, for remote access calls. Now, your data has to be serialized, fired over a physical wire, bounce through switches and firewalls and servers, and finally get deserialized on the other end.
This opens the door to the fallacies of distributed computing. We love to falsely assume that bandwidth is infinite, latency is zero, and the network is always reliable. Spoiler alert, they aren't. Plus, just tracking a simple user request now means you're dealing with complex distributed logging across dozens of servers, and you can pretty much say goodbye to simple guaranteed ACID database transactions. Systems like Amazon's Dynamo are explicitly designed to embrace what we call eventual consistency. That means updates happen asynchronously in the background, and you just resolve conflicts later, all to keep the system highly available.
So it perfectly illustrates the ultimate trade-off. You are deliberately sacrificing that amazing 5-star simplicity and low cost of a monolith. And what are you buying with all that increased complexity and operational headache? You're buying the multi-star elasticity, rapid scalability, and robust fault tolerance that really only a distributed system can reliably give you.
Section 5. Evolving your system.
Knowing all this, how do we actually get from point A to point B? I absolutely love this quote from the physicist Paracelsus, which is referenced in the book Software Architecture: The Hard Parts. All things are poison. The dosage alone makes it so a thing is not a poison. Neither a monolith nor a distributed system is perfectly good or totally evil. Architecture is all about deliberately choosing your dosage of trade-offs at exactly the right time. If you're looking to migrate, the smartest play is evolutionary, not revolutionary. Step 1. Organize your monolith logically around business domains. Clean up those internal borders first. Step 2. As you build new features, build them as external microservices that just talk back to the Monolith API. The Guardian newspaper did this brilliantly. They built temporary microservices for massive sporting events around their core Monolith API, which let them scale dynamically when traffic spiked. And finally, step 3, the hardest part. Gradually decouple and migrate your core data out of that central database. It takes time, it takes patience, and a whole lot of planning. Which brings us to our final thought for today. Where does your current system lie on this evolutionary journey? Are you still loving the simplicity and speed of a monolith, or are you starting to feel the serious friction of that scale wall? Analyzing your own systems through this lens of deliberate trade-offs is an absolute game changer for how you build and evolve software. Thanks so much for joining me for this explainer. Keep learning, and I'll catch you next time.